So my talk is titled Phoenix LiveView Demystified. The goal of my talk is to actually go behind the scenes of what makes LiveView possible. And as a disclaimer, this is not a tutorial of actually how to use LiveView. Out of curiosity, can I see with a raise of hands who has actually played with LiveView at some capacity? Okay, that looks about half of you. Is anyone running LiveView in production? There we go. Early adopters, love it. So let's actually get started with what LiveView actually is. But first, like was mentioned, my name is Alex Garibay. I work at Dockyard. I am also a member of the Phoenix core team. You can find me on Twitter with an _ Alex Garibay, just like ignored variables. I'm probably ignored on Twitter. And I'm also Alex Garibay on GitHub. If we take a look at the Phoenix LiveView docs, this statement actually comes directly from it. Phoenix LiveView is a library that enables rich, real-time user experiences, all from server-rendered HTML. And you might be thinking that this is quite an ambitious claim. Is that even possible? What does it actually mean to you? What this actually means is you don't have to immediately reach for some sort of front-end library or framework to have rich user experiences. What it actually means is that you can truly write some rich, interactive user interfaces using the tools that you're already familiar with in the Elixir ecosystem without needing to write JavaScript. You might need to write JavaScript, but definitely a lot less. But don't get me wrong when I make this statement. You still might want client-side JavaScript. It still does have its use cases, and you shouldn't discard it completely. But one of the benefits is that we can lessen the technical burden of developers by not making them learn JavaScript immediately. And obviously, you don't have to wrestle with Webpack for hours just to get your loader to work. But you can delay implementing client-side JavaScript until it's more of a hard requirement that will actually fulfill your business needs. And if you're unfamiliar with LiveView, you might be wondering, how is this all possible? What kind of wizardry is at play here? And is this really too good to be true? Don't worry, I'm going to tell you. It probably seems like magic at first glance. But if we take a closer look at this, we're actually going to see that LiveView is built on the tools and primitives that are already available to us in Elixir and Phoenix with the help of a little bit of client-side JavaScript a la Chris McCord. So Phoenix LiveView is actually comprised of three main things. We have LiveEEx, which is responsible for the templating. We have Phoenix Channels, which is responsible for the bidirectional communication over WebSockets. And we have some JavaScript. JavaScript's pretty minimal, but it is necessary, unfortunately. But our first stop is going to be at LiveEEx. LiveEEx is responsible for rendering our templates and rendering dynamic changes if we are in a stateful mode based on any data that changes within your process. LiveEEx is actually built on Phoenix's regular EEX template, which means you can use the familiar syntax that you're already used to if you are already using the templating system. And if you already didn't know, EEX templates and LiveEEx templates are optimized at compile time, and we'll actually dive into the details of this in just a moment. With LiveEEx, you can actually write your templates in two different ways. We can use an actual file where we render the whole template in a .leex extension file, and alternatively, you can use them inline using the else sigil. There's also an equivalent E sigil if you've never seen that before, but this lets you just write them inline in a file. But both of these forms are treated the same at compile time. And I actually want to walk through what the compiler sees because this is where all the cool change tracking actually happens. So say we have this inline template where we are just rendering a simple string of hello and some dynamic name that we're going to be pulling away from the assigns. When the compiler sees this template, it's going to be breaking up this string by certain delimiters, and one of those delimiters would be, the percent equal, and then, your assigned value. But when the compiler sees this is actually going to be in the AST form, the quoted form. You don't really have to understand it, but just know it does look weird, and it's not just you. But the LiveView engine, the LiveEEx engine, is going to try and separate out things that it can determine that are static, such as these string literals like this hello and this period, and the other things that are dynamic and that would require some dynamic evaluation at runtime. So it's going to actually separate these out into two separate lists. We're going to have this list of statics and dynamics. In the statics, we're actually going to put a placeholder variable where we're going to inject this value after it's evaluated. And then we're going to pull out the dynamic code and assign it to an argument, or sorry, a variable. And if you really wanted to see what this actually prints out and is injected into your code at runtime, this is actually what it looks like. Don't worry about completely understanding it, but the key thing here is to look at that case statement. So we're saying if this value changed at runtime and we know it changed, go evaluate it and return it. Otherwise, if it did not change, we're just going to return nil. When we actually are done compiling, we're actually going to get some sort of structure that looks like this. We have this rendered struct that's going to contain 3 keys. One of them is this static field, which is those string literals that I mentioned just a second ago. And we're also going to hold a list of dynamic values that we saw with those placeholder variables. And when we evaluate, I missed the most important part. This fingerprint. This is a uniquely guaranteed value that represents a template at any given time. So if we were to actually at runtime see a different fingerprint, that will signal that we are in a completely different template that's being rendered and just replace everything that you see. But at runtime, this argument is going to be evaluated and it's going to be filled and returned to the client, and change tracking will happen on the DOM and all that good magic stuff. So one thing that we can fill in with this dynamic is some optimizations or different types of data. And I want to walk through that real quick. We can have IO data, which would be string literals. We could also have nil, which means at runtime this value did not change, so don't go update it. We can also have another rendered struct, meaning we have a nested LiveView or nested templates being rendered at any given point. And we also have this one interesting thing called a comprehension struct. And this is for representing like 4 comprehensions. We didn't really want to send up this dynamic data every single time, so Jose Valim went and optimized this. And I want to actually walk through that real quick. So let's imagine we have this list of XY coordinates in this assigns called points. And we're going to iterate through this with a for comprehension. And we want to just output what that X and Y coordinate is with a label in front. So if we imagine this is what those values are, like a list of X and Ys, when we evaluate it, we're actually going to separate those out as well. We're going to have the list of statics and the list of dynamic values. And when we actually render this to the DOM, the statics and dynamics are actually going to be kind of like interleaved together to reconstruct what the entire DOM representation should be. So the reason we do this is so we send less data to the client. It's a small optimization, but these are some small things that Phoenix LiveView can do at compile time for us. Now that we've looked at how the templating briefly works and how these templates are generated, let's actually look at how this actually gets mounted to the DOM. There are three main ways of getting a live view onto our DOM. We could either route directly to a live view from the router using the live macro. From a controller, we can actually call live render, and this will just, instead of like render a template, render this live view. And additionally, you can render another live view template within a actual EEX template, and it's going to look exactly the same as the controller action, but they're actually differently namespaced. But when we do mount to the DOM, we're going to get what we call this container div, and this container div contains some information that LiveView needs on the JavaScript side as well as the server side. And if we look at this first attribute here, we have this ID. This is uniquely generated on every render, and this actually doubles as the Phoenix Channels LiveView ID. So whenever we connect a LiveView, it'll open a channel and join it where it matches this ID. And then we have this weird looking string, which is actually really shortened here, but it's some signed session data that will be passed to your LiveView on join, the channel process. This information in here includes some stuff like the LiveView module's name, the expected channel ID, which doubles as the ID of the element, some information about the router and endpoint, and maybe a parent PID if we are in nested LiveView land. But the key thing here is that this data is signed by Phoenix, so we have a tamper-proof way of providing data in a stateless manner to our LiveView processes when they are spawned on the server. And this last attribute here is data PHX view. This would just be your module name of the LiveView that would be called. JavaScript uses this as a query selector for finding some things. There's also a way to get this when you're in a JavaScript hook, which Chris will go into later in his keynote. Don't forget it. But it mostly acts as a query selector for now. One cool thing that most people may not know is we can actually change the container div to being something else. So if you have some particular markup that needs to be matched and styled, you can actually change this. By default, it's going to use a div, but if you provide a keyword option, you can change this by providing a two-element tuple where the first element is the tag name, and you can also provide some HTML attributes that are forwarded to the DOM to render. So if I were to change it to a p tag and I wanted to add a class, it would just be reflected when you render. The next thing I wanted to cover is Phoenix Channels. Phoenix Channels is the abstraction that gives us a mechanism for bidirectional communication between our browser and our server. And if you've gone through setting up a LiveView or integrating LiveView into your existing Phoenix applications, you would have had to have added this line to your endpoint. And all this does is open up an entry point into your application for a WebSocket endpoint, and it's actually going to use Phoenix LiveView's own socket implementation. And when we look at this socket module, we can see that Phoenix ships with its own single channel with the prefix of LV. So this is the topic that's used for all LiveView communication. And we also ship with our own implementation of a channel. And let's actually walk through what happens when we boot up a channel process for LiveView. So we're going to use this topic as an example topic, using some of the same data I showed off a few slides ago. Don't worry, it's not really important if you caught all that data. But when this process spawns, we're going to expect some data to be passed to it. So this supply data is going to be a map with some expected keys. If you're used to GenServers, this would be the data that's passed via like init or start link. So that makes it to where if our process dies, we can boot back up with the same exact data if we crash. But if we take a look here, this first key that we run into is params. You can actually supply client-side data to your LiveView processes. So if you needed some contextual information about your browser, such as like a time zone, you can provide that when you instantiate your LiveSocket object. It's actually in the docs, but it's a lesser known thing. But if you need client-side information, you can pass it along to your LiveViews and read it when you're in a connected socket. And we'll also get a key with our session data. This is that same session data we saw on the DOM from that data phx session attribute. But this data is useless to us unless we can decode it. And it actually looks a little bit like this internally. So we're going to have that ID, which matches our topic. We're going to have a little bit of information about our router, which actual LiveView we're going to be calling into, and any session data that we need to supply to our LiveView on mount. And since our LiveViews are actually channel processes under the hood, we can simulate what would actually happen when we get an event. So let's actually imagine that we have a button here that has a click handler attached to it, and it also has a value attached to it. And let's actually see what happens if we were to simulate this click. Our channel process is going to receive a socket message. We're going to receive an event type called event. It's not very descriptive, but this could also be something like a live redirect or some other event that's triggered from JavaScript. But for events, this would be the same for all event handlers, such as like blur or update or submit on your forms. We actually see this payload, which can provide some contextual information. So if you look to the left, we're matching some values here. So we have our event, which matches the myClick event, and some other data that's attached to the event handler. And this information will be called and invoked with our handle event callback in our view module. So like under the hood, like I'm mentioning, it's just a channel process with some callbacks in your module. I guess I'm going really fast. Okay. And I actually wanted to cover JavaScript because this is actually an important thing. If you didn't already know, Chris McCord absolutely loves JavaScript. So much so that he wants to write it for you. So if there's ever a JavaScript feature that you are wanting, please go talk to Chris McCord. So to connect the browser to our server over WebSockets, we actually need to instantiate this LiveSocket object. When we create it, we're actually going to pass in that route that we exposed in our endpoint. And when we actually instantiate this object, some top-level event handlers are attached to the browser's window, such events such as clicks and key presses. And like I mentioned a second ago, we can here provide some additional options to this object instantiation, such as params you want to send to your LiveView. You can add debuggers. You can even add some JavaScript hooks. I will not go into that today, but we have JavaScript hooks. And to actually bring our live views alive on the DOM, we actually have to call connect on our LiveSocket object. This will go through the DOM, and I'll go through that in just a second. But when we do that, we're going to go through the whole entire DOM. We have this query selector here, which will go through each entire element on the DOM to see if it has this data phx view attribute, and if it's not, some nested live view. And this would be considered like the root container of our live view. And each live view, live view has this JavaScript class, which is used to hold some information about our live views. Such information such as the current DOM node and scope, the live views ID, which doubles as a channel ID, and the current state of the things that should be rendered, or the current state of the world that it knows of. So every live view container that we find, we create a brand new object. And each object then will add the appropriate event handlers to the live view, and it'll also intercept any events coming from the server, so you can handle them if you need to via hooks. And these events also include such things as like live redirects and diffs that come from the server. And once we have this new view object, we join a channel. When we join the channel, the server is actually going to reply back with some information about the new state of the world. So if I haven't mentioned this, your LiveView's mount function is actually going to be called twice. So we have the normal HTTP response, the get, that's going to return back some static HTML. And when you have your LiveView process connected via JavaScript, it's going to be executed again, and that's going to have a potentially different state of the world. And I actually want to walk through what that would look like. So our server is actually going to reply back with this rendered representation of what we saw a few slides ago from like LiveEEx. So we're going to have a section on some static data, which would be like the things that aren't going to change very often, and then we're going to have some placeholder information for things that are dynamic. And just like before, when we interleave these things, that will give us the actual representation of what the DOM should be. So if I were to assign some variables to this, I wanted to walk through like how LiveView would actually do this. So like I was mentioning, it's actually going to interleave each item from each static value. And then at the very end, it's going to be reconstructed into a total string, which then would be applied to the DOM. But one good feature of LiveView is that we have change tracking, and we're going to apply diffs to the DOM if our data changes. So if we were to receive a diff from the server due to some event that we triggered, we're going to receive a diff, and if our value changed, we're going to get a placeholder value for it. That value is going to be merged, so we saw that that 0 index was the dynamic data, and it's going to be replaced with that dynamic data, and we're going to have our whole new state of the world. And we need to apply this to the DOM with an efficient diff mechanism, and we actually use Morphdom.js for this. Unlike popular JavaScript libraries such as React or Vue, Morphdom does not have a virtual DOM. Its whole benefit is that it uses the real DOM as the source of truth, and it actually is pretty fast for certain size of diffs. And we could just replace the whole DOM node if we really wanted to, and delete it and replace it, but that's not really a good practice, because if you have some sort of animation being applied to your HTML element, or there's some scroll positions that you're using, you're actually going to mess up your user's view. So what Morphdom does, it just does the minimal diff to get that new state of the world. And Morphdom's API is actually really straightforward. You find an element on the page that you want to change, and then you give the new representation of what you want it to be, and you just say, hey, Morphdom, here's what I want, here's what I have. And this example actually comes from a blog post from Chris McCord. If you look at it, if you're in Google Chrome and you're inspecting the HTML, things that highlight are the things that change on the DOM. And if you can see, Chris is actually moving a slider around, but only a few fields actually change. So instead of replacing that whole DOM element, we're only replacing the things that need to be changed. So now that I've actually walked through really fast, I guess I'm doing good on time. Never mind, excuse me. Putting it all together, how does this all fit together in the individual pieces? So let's imagine we have our browser and we have a server. Our browser is going to make a GET request to our server. Then our server is going to reply back with our static HTML. Then some JavaScript is going to be loaded on the page. Our JavaScript is going to start that WebSocket connection, which will actually boot up a LiveView process on the server. Our LiveView process is going to respond back with what the state of the world should be, knowing that we have this booted process. And it's going to send it up to the JavaScript to handle. And this JavaScript is going to update its known state of the world, and it's going to re-render via Morphdom. And if we were to add some sort of event handler, such as a click, that click event is going to be pushed down to our LiveView process. Our LiveView process is going to handle it, update its assigns, and we're going to have a new state of the world with a diff or even a new template that's going to be rendered altogether. It's going to push it back up to the JavaScript. We're going to get our new state of the world, and this cycle continues on and on until your LiveView process dies or you just leave the page. So again, I think I went through this really quick, but to recap, what we talked about was, the three main things that really make LiveView possible, and it's all done through the things that we're already familiar with. We have LiveEEx for the templating system. We have Phoenix Channels for the bidirectional communication. And then we have JavaScript as like the glue to make it all possible. And that's all I really have, and I appreciate you all coming to my talk and listening.